Hello students, this is Venkatayadiri, chemistry classes. So today's topic is that equivalent mass, lesson number 3, topic 3, numericals. We'll continue the numericals. So in L1 and L2, lesson 1, lesson 2, lesson 1 theory we completed equivalent mass, and lesson 2 also some of the numericals we completed. Next we'll continue the numericals of the equivalent weight. So this is the last. Now 9.8 grams of the sulfuric acid is neutralized by how many grams of the sodium hydroxide? How many grams of sodium hydroxide? Now here the sulfuric acid is reacting with sodium hydroxide. So one equivalent of sulfuric acid reacts with one equivalent of sodium hydroxide, or 1 gram equivalent weight of sulfuric acid react with 1 gram equivalent weight of sodium hydroxide. That is a concept. So E, small e is that, so mass by divided by capital E, that is equal to mass divided by capital E. So mass of the sulfuric acid divided by equivalent weight of sulfuric acid, mass of sodium hydroxide divided by equivalent weight of sodium hydroxide. Now in last class we completed like this, mass is directly proportional to capital E. Now based on that one, so sulfuric acid mass is the 9.8, okay, upon equivalent weight of sulfuric acid. Sulfuric acid equivalent weight is 49. 49 is the sulfuric acid equivalent mass. Now here equivalent mass is equal to gram molecular weight by valency. So if you go to the equivalent weight of the sulfuric acid, gram molecular weight of sulfuric acid is 98 divided by n factor of the sulfuric acid, 2 hydrogen, therefore 98 by 2 is equal to 49. Now that is equal to, second one is mass of sodium hydroxide. He is asking the mass of sodium hydroxide. Let us, it is a m divided by sodium hydroxide. So equivalent mass of the sodium hydroxide is equal to gram molecular weight of sodium hydroxide is 40, and valency factor is acidity, OH groups 1. So 40 by 1 is equal to 40. So m divided by 40. Now if you calculate mass after calculation, then you will get the, so this is the 49 ones are 49 twos are 0.2s are, so 0 0 cancel, 4 2s are 8 grams. So answer is the B. Yes. The next numerical is that gram equivalent weight of carbonate ion is gram equivalent weight of carbonate ion. If the ions are given, then gram equivalent weight is equal to formula mass, formula weight or formula mass divided by n factor, valency. So carbonate ion CO3 minus 2, if you calculate, carbon is equal to atomic mass 12, oxygens are the 3, 16 is atomic mass of the oxygen, 16 3s are 48. So if you calculate, you will get as a 60. So 60 divided by valency factor is nothing but, you have to see the shortcut is that charge. Charge of this ion is 2. Therefore minus 2, we have to take the positive. Therefore 60 by 2. 60 by 2, A is the option. Okay. Okay. Now the next problem is that 27 grams of aluminum metal is dropped in dilute acid. Then how many liters of hydrogen gas is liberated at STP? Now this numerical we have to calculate with the gram equivalent weight concept, equivalent mass concept, right? Now here m is directly proportional to E. This is the basic formula. Okay. Now m by E is equal to number of equivalents. So m divided by m, mass of aluminium metal divided by mass of second component is the hydrogen. So hydrogen, that is equal to equivalent mass of aluminium divided by equivalent mass of the hydrogen. So mass of aluminium is 27 grams, okay, divided by mass of hydrogen. You have to calculate, we have to calculate, that is equal to equivalent mass of the aluminium, that is a 9 divided by equivalent mass of the hydrogen is equal to 1. Now we know that one equivalent mass of the aluminium is equal to gram atomic weight divided by valency. Gram atomic weight of the aluminium is 27 and its valency is equal to 3. 27 by 3 is equal to 9. Now in the same sense, equivalent mass of the hydrogen is equal to gram molecular weight is 2 and 2 into plus 1 divided by 2, that is equal to 1. So hydrogen 1. And if you calculate 1s are, this is the 3s are. So mass of hydrogen we are getting, mass of hydrogen gas that is liberated is nothing but a 3 grams of the hydrogen gas is liberated. But he is not asking the mass, he is asking the how many liters under the STP condition. Now come to the step 2. Now according to the mole concept, 1 mole is nothing but a gram molecular weight. Gram molecular weight is equal to 22.4 liters. 1 mole of any gas can occupy 22.4 liters at STP. The molar mass of the hydrogen gas is 2 grams. So 2 grams of the hydrogen gas can occupy 22.4 liters. Okay. Now here the liberated hydrogen gas is the 3 grams. So 3 grams of hydrogen is equal to X liters. After calculation, you will get as a 33.6 liters. Okay. Right. The next numerical is that 2.4 grams of the magnesium metal is dropped in dilute acid. Then how many liters of oxygen gas is liberated at STP? So here the magnesium metal is dropped in acid and it is liberating the oxygen gas. So again same principle, mass is directly proportional to the capital E, and mass of magnesium metal divided by mass of oxygen gas, that is equal to equivalent weight of the magnesium divided by equivalent weight of the oxygen gas. Okay. Now if we take in mass of magnesium metal is the 2.4 grams divided by mass of oxygen, we have to calculate first of all mass of oxygen gas, that is equal to equivalent weight of the magnesium is the 12 and equivalent mass of the oxygen is 8. Okay. Now here, so mass of oxygen, how much you will get? This is 12.12 ones and this is the 0.2 and 8 2s are 16. Therefore, mass of oxygen is equal to 1.6 grams. Mass of oxygen is 1.6 grams. Next, after getting the mass of oxygen, but he is not asking the mass of oxygen, he is asking the equivalent mass of the, sorry, how many liters of oxygen, he is asking the volume of the oxygen. Therefore, again same concept, 1 mole of any substance is equal to gram molecular weight and 1 mole of a gas at STP can occupy 22.4 liters. Here our compound is oxygen, therefore gram molecular weight of the oxygen is 32 grams. 32 grams oxygen can occupy 22.4 liters. But here we got 1.6 grams. So 1.6 grams of oxygen can occupy how many liters? X liters. So if you calculate cross multiplication, if you do, then answer you will get as a 1.12 liters. Right. The next numerical is that AClX is a chloride of capital A element. AClX molar mass is given as a 170 and gram equivalent weight of capital A element is 7. Calculate X value, that is nothing but a valency of A or N factor he is asking. Now here two data is given. So one is the 170 and second one is the 7. Okay, two magnitudes are given, 170 and 7. 7 is the gram equivalent weight of capital A and 170 is the molar mass of the AClX. Now if you see gram molecular weight of AClX, generally what we will do, that is equal to gram atomic weight of capital A plus and X times of gram atomic weight of chlorine. Gram atomic weight of chlorine. Next, this is equal to, but we know that one, gram equivalent weight is equal to gram atomic weight divided by valency factor. So here the gram atomic weight of A is given. So gram atomic weight is equal to gram equivalent weight into valency. So we can able to write like this, gram equivalent weight of capital A into its N factor. its n factor is nothing but a x is the its n factor. Its x is nothing but n factor. Now x comes here. So x comes here plus x and 1 goes there minus a minus 1. So x is nothing but a valency of that a. So gram equivalent of capital A into x. X is nothing but a valency factor plus x times of gram atomic weight of chlorine. So if you calculate, gram equivalent weight of capital A is given as a 7. So 7 times of the x, 7x plus and x and gram atomic weight of the chlorine is the 35.5 into x times. Now, but gram molecular weight of ALX is given as a 170. Therefore, 170 is equal to 35.5 plus 7. 35.5 plus 7, that is equal to 42.5x. Now, if you divide, so x is equal to 170 divided by 42.5. So you will get as a 4. Means that the valency of the A is a 4. Means AClX is equal to ACl4, or that is nothing but the oxidation number of the A is the plus 4. So this is the answer. Okay. The next question is that chlorine in presence of the alkali medium that is undergoing disproportionation and gives the Cl minus and ClO3 minus. And he is asking the gram equivalent of the chlorine is equal to how much? Options are A, B are given, right? Now here Cl2. So if you go to the answer Cl2, here oxidation number of the chlorine is 0 and this is the Cl minus 1. Cl minus 1. 0 to minus 1, it is a reduction. The process is what? Reduction. And the next one is that same chlorine Cl2, oxidation number is 0 and ClO3 minus 1, chlorate ion. Here the chlorine oxidation number is the plus 5 after calculation. Now this process is the oxidation. Why? Because 0 to plus 5, increase of the oxidation number. Now we have to calculate first of all n factor or valency factor for this one. So Cl2, 2 chlorines are present. Now that is 2 Cl minus 1. 0 to minus 1, 1 electron. But 2 chlorines are there, therefore 2 electrons are exchanging. Therefore valency factor for this one, valency factor is equal to 2 and capital E here, that is nothing but a capital E of chlorine in this case in the reduction, that is the capital M divided by valency factor 2, M by 2. Next, come to the oxidation. Cl2, it is converting into the Cl plus 5. It is undergoing oxidation by loss of the 5 electrons, but this is for 1 chlorine. But here the 2 chlorines are there into 2. And how many electrons are transferring? 10 electrons are transferring. Therefore, valency factor is equal to 10. Here the valency is equal to 10. Now, beta, here 2 and 10 we are getting. 2 and 10. So, just a small thing I am removing this is, we can take the ratio. Left side in reduction 2 and the right side in oxidation 10. We can take the ratio as a 1:5. Therefore, capital E of chlorine is equal to capital E of chlorine in reduction process plus and equivalent weight of the chlorine in oxidation process. That is equal to mass divided by equivalent weight M by 1 plus M by 5. Okay, 1 by 1 plus M by 5. Simple LCM and simple calculation if you do, then you will get as a B is the answer. Okay, so that is equal to 6M divided by 5 is the answer. So equivalent mass of the chlorine is equal to 6M by 5. Okay, up to this one is clear. Now they may ask in this reaction what is the N factor of the chlorine? What is the N factor of the chlorine? If we take gram equivalent mass is equal to molar mass divided by valency. That valency is only the N factor. But we got the gram equivalent weight as a M. So what we got? 6m divided by 5. So molar mass divided by valency. So n factor, if we say n factor is equal to 5 by 6 is the n factor for this example. Okay. Alright. So the another question. Gastric juice contains 2 grams of HCl. So gastric juice contains 2 grams of HCl per liter. So 1 liter of the gastric juice contains the 2 grams of the hydrochloric acid. If a person produces 2 liters of the gastric juice per day, how many antacid tablets are required containing 500 milligrams of the aluminum hydroxide to neutralize all the HCl produced? So in our gastric juice, HCl is present, hydrochloric acid is present. So to neutralize that hydrochloric acid, we are taking the antacid tablets. That antacid contains the aluminum hydroxide. So how many tablets are required? So first of all, 2 liters of the gastric juice. So therefore mass of the HCl produced per day, that is equal to 2 grams of the HCl per liter into the how many liters is the 2 liters. So 2 into 2 is equal to 4 grams per day. Means 1 liter of the gastric juice contains the 2 grams of the HCl, 2 liters contains 4 grams of the HCl. Next, according to the law of equivalence, mass is directly proportional to capital A. Here the hydrochloric acid and aluminum hydroxide relation we have to take. So mass of aluminum hydroxide divided by mass of the HCl is equal to equivalent weight of aluminum hydroxide divided by equivalent weight of HCl. Mass of aluminum hydroxide, so that we have to calculate how many antacid means that we have to calculate the X, and mass of HCl we calculated as a 4 grams is equal to equivalent mass of the aluminum hydroxide is 26 and equivalent mass of the HCl is 36.5. Now HCl, hydrogen is 1, chlorine is 35.5, so molar mass is the 36.5 and its valency is equal to 1. Now how the equivalent mass of the aluminum hydroxide is equal to 26? We know that 1 gram equivalent weight is equal to gram molecular weight divided by valency. Gram molecular weight of the aluminum hydroxide is 78 and its valency is equal to 3. Why it is the valency is 3? Because OH groups, base is there na. So number of OH groups are the 3, therefore 78 by 3 is equal to 26, right? Now here these total values are substituted. Then if X is calculated, we are getting the 2.85 grams of the aluminum hydroxide is required for complete neutralization of the 4 grams of HCl. Next, but he is not asking the quantity of the aluminum hydroxide. He is asking the number of tablets, antacid tablets. Now here 500 milligrams of aluminum hydroxide is present in one tablet. 500 milligrams of aluminum hydroxide is present in one tablet. Therefore, but here the 2.85 grams, 1 gram is equal to 1000 milligrams. Therefore, 2.85 into 10 power 3 milligrams of aluminum hydroxide is neutralized by Y tablets. So, after doing the cross multiplication, we are getting as a 5.7. 5.7 is equal to 6 tablets. Okay. Now this is about the equivalent mass calculations. Numericals we completed, and please watch the lesson number 1 for theory, lesson number 2, lesson number 3 is nothing but a for numericals of the chemical equivalent weight, that is a gram equivalent weight. Okay beta, right? So if you like this video, subscribe, share it, and watch the videos continue.